Hello everyone, this is Teacher Reggio. This is a lesson on quadratic equations, and we are going to address the competency illustrate quadratic equations. First, we have here the definition of quadratic equation. It is a polynomial equation of the second degree. It is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. So this means our variable here is just x because this a, b, and c are real numbers. I have here three equations. Can you identify each as quadratic or not quadratic? Let's look at example or item number 1. X minus x cubed plus 1 equals 0. Is it a quadratic equation? No, it's not. Why? Because the highest exponent here is 3. Our definition states that it is a polynomial of the second degree, meaning to say the highest exponent is just 2. How about equation number 2? X to the power of negative 2 plus 6x equals 0. Is it a quadratic equation? No. Why? Because even though we have a 2 here, it's not a positive 2, but it's negative 2. So therefore, it's not a quadratic equation. How about item number 3? Is it a quadratic equation? 3 minus x squared equals 0. Yes. Why? Because the highest exponent is 2. Now, we have here the standard form of the quadratic equation. So ax squared plus bx plus c equals 0. This first term with exponent 2 is what we call the quadratic term. And the second term here, okay, with x and exponent is 1, understood there's exponent 1, is what we call the linear term. And the third term we have here plus c is what we call the constant term. Even if we do not have the linear term or the constant term, or both the linear and the constant terms, our equation is still a quadratic equation if we have the quadratic term. Now, it is very important that we will be able to identify or to tell the values of a, b, and c. Why? Because, for example, in the quadratic formula, x equals negative b plus minus square root of b squared minus 4az all over 2a. Yeah, this is the quadratic formula. You can see that it uses the letters a, b, and c, which are actually, okay, the values of a, b, and c are those that we have from the given quadratic equation. And in finding the vertex of the graph of a quadratic function, we also have the letters a, b, and c. And also in finding the value of the discriminant, okay, it also uses the letters a, b, and c. Now, we will have an example here, okay, in writing our quadratic equation in standard form and giving the values of a, b, and c. We have here example number 1, write x squared minus 4 equals 3x in standard form and give the values of a, b, and c. So this is our equation. All we need to do is to arrange this equation, okay, so that it will follow this form: quadratic term, linear term, then constant term. So this is how we arrange it. So notice here the 3x is on the wrong place because it is on the right side, because the form here states that okay, the a, okay, x squared should be the first term, and bx should be the second term, and c should be the third term. So notice here that our 3x is from the right side. We move it to the left side, it becomes negative. Now, what are the values of a, b, and c? Okay, we have a equals 1. If you don't see 1 here, it's implied that if you don't see the coefficient of x squared, it's understood to be 1. Then b, negative 3, and c, negative 4. Now we have another example here. Write x times the quantity 4 plus 2x equals 0 in standard form and give the values of a, b, and c. Now, actually, we can remove the parentheses by applying the distributive property of multiplication. First, we have to multiply x and 4. Okay, that's 4x. And then we multiply x times 2x. That will give us 2x squared. Then equals 0. And then we are going to arrange. Okay, so the first term should be the quadratic term, linear term, and constant. Okay, we will arrange. So we have 2x squared plus 4x equals 0. So what are the values of a, b, and c? So a here is 2, b here is 4, and notice here that we don't have the constant term, so c equals 0. Now, example number 3. Write the quantity x minus 3 times the quantity x plus 2 equals 0 in standard form and give the values of a, b, and c. So actually, we can remove the parentheses by multiplying the two binomials. And in multiplying the two binomials, we can use this method. We call this one FOIL method. So this implies that we are going to do multiplication 4 times. So f, this means multiply the first terms. Then o, multiply the outer terms. Then I, multiply the inner terms. And then L, multiply the last terms. Okay, now let's start. Okay, x and x are the first terms. First term of the first binomial and first term of the second binomial. X times x, x squared. Then next is outer. X and 2. That's outer, so that gives us 2x. Then inner. Okay, inner terms here, negative 3 and x. Okay, that's negative 3x. Then last terms, negative 3 and 2. That gives us negative 6, and of course we have there equals 0. Now we can combine these two terms here, plus 2x minus 3x. So that gives us x squared minus x minus 6 equals 0. And the values of a, b, and c are a 1, b negative 1, and c negative 6. Now I prepared 2 items here, okay, for your exercises to work on. You can pause the video and work on these 2 items. If you are ready, I will show you now the answer. Okay, for item number 1, okay, the standard form is 2x squared minus 7x minus 4 equals 0. And then a is 2, b is negative 7, and c is negative 4. For item number 2, the standard form is 3x squared minus 17x plus 10 equals 0. A equals 3, b equals negative 17, and c equals 10. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Regil. Keep safe.